relatively quiet. We saw a few filaments pop in the opening sequence. There's bubbling and boiling in preparation for increases in sunspot activity, which you can see building as the plague areas surrounding the sunspot on the north. During sunspot maximum, the entire whitish plague field would be populated with sunspots, likely flaring. Solar wind is calming at an above-average telemetry. Plasma speed is elevated, but steady, allowing Earth's field to adjust after the brief geomagnetic storm that occurred upon impact. Let's head over to the ESA and the plasma wind tunnel used to test satellite re-entry. Testing one of the stabilizing housings here, one that's known to present a burn-up problem for satellites that need to stay trained on one object, like solar satellites. Up next is Mars. Dust seen during the test flight of the helicopter is making them wonder if tracking the trail from overhead will look like the trails left by the Martian dust devils. It's an unexpected cross-evidence potential for study. Up next, we're at Chandra, doing an X-ray survey of superflares and megaflares. They've provided a number of infrared and X-ray combination shots to show where in the vast and busy fields the flaring stars can be seen. Largest such survey ever, with complimentary video on how massive flares can strip a planet and turn it from Earth-like into Mars. Last but not least, folks, that anti-nova story from a few days ago gets play in this one as it is confirmed. It wasn't a random blob of dust and gas that got in the way of Betelgeuse last year, dimming. The star did it itself. A massive dust production and shell shedding event from the star. A micronova. If we broaden the applicability of such astronomical light curves to include these events, it makes such miniature blast-offs one of the more prominent features of the heavens. Stars have tricks up their sleeves, and observers quietly apply this fact to the sun. We greatly